Hello, everyone. Good evening and welcome to African Women in GIS 7 Days Masterclass in GIS for Beginners. Welcome. This is day 6 and I'm super excited we have come this far. Today is the second to the last day and it has been a wonderful section from the beginning. And I believe most of our viewers and participants, we have met your expectations. So if you've joined us, kindly say hi, introduce yourself, and tell us where you are watching from. If you can hear me, can you comment on this comment section, introduce yourself, and tell us where you're watching from. Hello. I can see you, Amin Nugunmi. Welcome to day 6. Welcome okay, thank you. You're watching from Abuja. Thank you. You're welcome. Can we get one more or 2 persons? Then we can kickstart. We want to make sure that our participants are live. Hello, Ruva, watching from Namibia. Windhoek. I would want to be there someday. I have a friend from Namibia. Thank you, Ruva, for joining us from Namibia. Welcome to today's section. Thank you for joining us from Uganda. Emmanuel. We can see 7 people have already joined the live section. Can you tell us where you're watching from? If you can hear me, can you comment on the section? Yes, Ruva. Sure, thank you. Can we get 1 or 2 more persons to tell us where they're watching from? Then we can kickstart. This is to make sure that we have we are carrying everybody along. We don't want to leave anybody behind the scene. So please tell us where you're watching from so that we can know we have people active waiting for us. Olabisi, thank you for joining us from Nigeria. Thank you, Nicholas, for joining us from Uganda. Mafuza, thank you for joining us from South Africa. I think we are good to go. Without wasting much of our time, we just don't want people to join us and and they get lost along the line. We want to make sure that everybody is participating. So we would like to give one more minute and we will start the section. We want all our active participants to be available. We don't want to leave anybody behind. 1 minute, introduce yourself and tell us where you're watching from if you're joining now. Thank you, Damilola. We can see you. We hope we are meeting your expectation. We know we can't cover everything, but we are trying as much as we can to cover as much as we need in our everyday GIS analysis. So while we are waiting for some of the participants to join in the section, I would like to introduce Edna Simba. She is going to be taking us today. Today is day 6, and today is the second to the last day of the training section, and we are super excited. We have come this far, and today we are going to be taking land use and land cover classification. Remember, on day 4 we did introduction to remote sensing and image classification. It was a powerful section, and a lot of people I know are really looking up to this section. So today we are going to go to land use and land cover classification, and we are also going to be taking on modeling land surface temperature. So you get to know how do we model the surface temperature of the land using GIS. So such a beautiful topic to learn. And tomorrow, which is the last day, we are going to deal with hydrology, watershed analysis, and NDVI. So because today is the second to the last day, we would also be sharing the registration link. So please, if you haven't registered and you have been joining this session, please kindly register so that we will be able to reach you to send across the assessment and also to send across the certificate. It's not going to be fair to leave some people behind because we noticed that a lot of our active participants didn't make it to the registration deadline. So we will drop the registration link soon so that you can register. If you know someone who is also part of the section and haven't registered, please kindly also share the link when we drop it. So the last day, which is tomorrow, we are dealing with hydrology, watershed analysis, and we are also diving into NDVI for vegetation. So without wasting much of our time, we have 16 viewers now. I think we can continue the section, but if you happen to have any question, please drop a comment on the comment section and we are here to answer your question. So I'll drop the registration link. Praise, thank you for asking how you can register. I'll drop the registration link on the chat comment. So kindly click on it to register if you have not done so. So going straight to modeling land surface temperature, I would like to introduce Edna. Edna, welcome to today's section.
Thank
Over
you,
to you.
Nana. Good evening, guys. It's evening over here in Nigeria, wherever you are. Thank you for joining today's session. So today we are going to be seeing how we use QGIS to model land surface temperature. So I'm sharing my screen. I'm sharing my slides. So we just get into the business of the day. So firstly, what's this land surface temperature we are interested in modeling? Land surface temperature, from the definition we can see here, is defined as the temperature of the interface between the Earth's surface and its closest atmosphere. So what we're interested in now, we are trying to get the temperature of the Earth's surface using remote sensing data. As Nana said on day 4, Chidima introduced us to remote sensing, basic modules on remote sensing, and from there if I remember correctly, could see all the different uses of remote sensing, and then modeling land surface temperature is actually one of them. And the part of remote sensing that we use in this is the thermal remote sensing. So land surface temperature, is very, very crucial. It's a very, very crucial measurement because we use it in so many applications. Some people use it to calculate the evotranspiration, hydrological cycle. People use it for vegetation monitoring, use it for environmental studies, and a lot of things. So now, this land surface temperature, basically, without using remote sensing, you can equally estimate land surface temperature with radiance measurements from meteorological stations. But now, if you decide to use measurements from meteorological stations, you can't cover you can't do large scale monitoring, as it was already explained to us before. When you use remote sensing, you get to cover a very large area. So when you are trying to model land surface temperature using remote sensing, it's actually it's a good step because you get to monitor LST on a very large scale, even globally, if you have the data set. So now, this thermal remote sensing we're interested in, what it does is, this part of remote sensing captures radiation emitted from the ground, and then those radiations are emitted from the ground. We, the users of this data, we use it to estimate surface temperature. So here we can see we have methods of LST determination using satellite imagery. In this case now, the satellite imagery we'll be using is Landsat 8. So when you want to use remote sensing or satellite imagery to determine LST, there are some methods and algorithms that have already been developed for you to use to get the data you need. So now the satellite data we're interested in, if I the satellite data we're interested in is the thermal infrared band. Now, for every satellite imagery, that's if you are using Landsat or you decide to use Sentinel, they have bands. So all these bands, they have different properties. So now we chose to use Landsat data because it has the infrared thermal infrared band, and the thermal infrared band is the band specifically used to determine LST. So that's why we have here saying that the TIR actually stands for thermal infrared, that TIR data is necessary to model LST. So the various algorithms and methods that have been developed to model this LST from thermal infrared data, we have the split window algorithm. This is actually the most popular method used. We have temperature emissivity separation method. We have the NDVI threshold method. We have single channel algorithm, mono window algorithm, and the radiative transfer equations. So you can equally read on all these methods that have been developed. They've been developed by individuals, so you can read up on it. So now, like I said, the data we are using specifically for today's session is Landsat 8. So Landsat 8, the full name is actually Landsat 8 Operational Land Imager and the Thermal Infrared Sensor. So this Landsat 8 has two thermal bands. They are band 10 and band 11. So now when it comes to modeling LST from Landsat 8, um, people have carried out studies and they've come to the conclusion that users should refrain from the use of band 11 for quantitative retrieval of LST because band 11 has large calibration uncertainties. So which leaves band 10 to be the most preferable band when using Landsat 8. So now, when you want to use Landsat 8 to model LST, there are steps. So for the fact that we are using QGIS has QGIS has plugins that have already been developed with all these steps. So if we're to use another software, other softwares to have plugins and different tools. But if we're to use, let me just put an example. Okay, if we're to use something like ArcGIS now, we'll have to be calculating each of these one by one. And so if we have to, when we want to calculate this one by one, the first thing we do is we calculate our radiance images. Now, what these radiance images are, the data we have, like the band data, that's the band 10 data we have, is just bare. It just has digital numbers. Okay, the data is just there. Okay, so there's a need for us to convert that data to spectral radiance data. So this is the formula we that is being used, and then you can see that we use the radiance rescaling factors. All these factors are provided in the metadata file. Still show you what the metadata file is. So these are all the steps involved. We have this the step 1. We have this as our step 2. Please I'll still share this material with this slide rather with you guys. So I think I just give a run through from here. The next thing you do, you calculate brightness temperature from your radiance images. Then you calculate NDVI, you calculate emissivity. Then after you've calculated your radiance images, your brightness temperature, your NDVI, your emissivity, Those are the things you use to now calculate your LST. So now I've given a rundown of how you calculate LST from Landsat 8. So I think we can move into a hands-on session. But I don't know if anybody has a question. So before we start, a document was shared. I believe a document was shared to you guys before this session started. So there are some requirements that are supposed to fulfill before we start modeling LST with QGIS. First things first, when you want to start your QGIS, please always start your QGIS. The one you should start is the one that has grass. QGIS desktop, whatever version you have with grass, always start that one. It's important. Then there's a link to download your data. There's a link to download your data. So uh, I would I would share that link now, but I want to believe everybody has the data, because the data I'm sharing now is actually Landsat data. But I'm still going to show you guys how to download or access Landsat data on your own. So if you have the data, you need to sorry for that, unzip your data. So, for those of us that joined yesterday's session, during my session yesterday, I gave a rundown on how to install plugins in QGIS. But the one we did yesterday was how to install plugins from zip files. So today's owner, we are going to see how to install plugins from the QGIS plugin repository. The repository is like a QGIS library of all the plugins available. So these are all the plugins we are going to download. We are going to download the SCP plugin. This SCP plugin we use it, it's used for various purposes, but the purpose we are interested in, we are going to use this SCP plugin to download Landsat data. So the next one we are going to download is the RS and GIS plugin. This is the one we're actually going to use to carry out our LST retrieval. Then this data plotly, we are going to use it to plot a scatter graph, or to plot a scatter plot. So with this, I'll stop sharing my screen here, because I think we can begin with our analysis, but there's something we need to do first.
So please, if you have any question before she starts the section, maybe you can drop it on the comment section. Someone says, how can I get the certificate? So please go through the comments. We have dropped a link to register if you have not registered. The email addresses we have, where we are going to send the assessment across to you, and that is where we'll also send your certificate. So please kindly re-register. And if you have registered and you have not been getting any email from us, please kindly check your email, because some of the email addresses we have are not correct. So the emails bounce back. So if you have not been receiving any correspondence from us, please kindly register again and rectify your email address. Thank you.
Okay, so this was the document that was actually shared. So, excuse me. First things first, for you to access Landsat data, there's a website called Earth Explorer, but there are other websites where you can download Landsat data. But the one I use, and I think that's the most popular one, is the USGS Earth Explorer. So before you are able to access Landsat data, you need to create an account on Earth Explorer. And to create an account, this is the link. So I'll just click on it and give a rundown on how to do that. So if I click on it, it's loading. So this is where it will bring you to, but as you can see, I've already created an account, so it's telling me to log out. But if you've not already created an account before, these are just what you need. You just need to get a username and a password. So when you press continue, you will see somewhere where you have to put your email address, and then you answer a few questions, and you are good to go. So that's that's the first step in accessing Landsat data. A you need to have an account on Earth Explorer. So with that, I believe I'll just I'll start sharing my screen in QGIS because I've already downloaded the data, and I believe most of you guys too have already downloaded the data. So I just open my QGIS. So this is my QGIS interface. So what we are going to do now is we are going to install the plugins that we need. That's what we are going to do now. We are going to install plugins. So first things first, you come to your the menu toolbar, you click on plugins, then you click manage and install plugins. So as you see now, you need to be connected to the internet to do that. So when I click on it now, I'll go to all. So under all, this is where you search for the first one. The first one we need is SCP plugin. What SCP actually means is semi-automatic classification plugin. So when you search for SCP, you see semi-automatic classification plugin. You click on it, then because I already have mine installed, that's why you see here. But if you don't have it installed on your system, you click on install plugin, then the plugin will install. The next plugin we need to equally install is the GIS, RS and GIS plugin. This is actually the plugin we are supposed to install. RS and QGIS. I'll just copy it all. RS and QGIS. You don't leave any space when you are typing on it. You click on it and you install it. Then the next one we want to install is the data plotly. So click on data plotly and we install it. So that's how you install the plugins we need for our session. So I'll close that. I believe everybody is following. Okay. I believe everybody is following the session.
Yes.
Okay. So now I believe we've all installed the SCP plugin, and we've equally downloaded our data. So what I'm going to do now is, if you've downloaded your data, these are the data we need. We need our shapefile of our area of interest, the area where we want to calculate LST for. Then, like I said, I already took liberty to download Landsat 8 imagery. So I downloaded Landsat 8 imagery for 2016 and 2021. So even if you've not done this, let me just show you how you do it using the SCP plugin. So all you need to do is you click on plugins. You click on plugins. Then if yours is not showing here, it's not a problem, but you've installed it. All you just need to do is plugins, manage and install. I closed mine, that's why I couldn't see it here. So I'm just trying to switch it back on. So I'll close it back. So this is you see something like an SCP doc. So now you can see I can see it here. So when I have the SCP plugin back installed, all I have to do now is when I click on it, I'll see download products. I'll click on download products. So now the first thing you do when you open it, now that you are on download products, let me just give a rundown. The login data you created on Edge Explorer, all you have to do is you just have to enter it here and click on remember. That's one. That's the first thing you do. You have to put your login details there. So the next thing I'll do again is I have to add my area of interest shapefile. So I go to add layer, add vector layer, then I'll move to where I have it saved. I'll add it, I'll click on add, then I'll close. So this is my area of interest. This is actually a local government in Nigeria. It's called Makurdi. So that's the my area of interest for today. So I'll go back here on SCP, download products. I'll go to search. So now when you are on this on search now, I want to download Landsat data that is related to this place. You click on this plus sign here, set area in the map. So I click here. What you do is you left click the left hand side of your area of interest, and you right or equally right click the second area of interest. So now what I've done is
Sorry to
I
cut in. I think we're not seeing. Okay.
we are what?
Okay, go ahead.
Okay.
Sorry,
So
go ahead. We can see now.
okay, I'm sorry if you couldn't see before. So what you do is when you click on this set area in the map, you come back to your area of interest, you left click the left hand side of your area of interest, and you right click the right hand side of your area of interest. When you've done that, what you are trying to do is you are trying to set like you're trying to set the area it's like the plugin should search for products for you for. So I've done that. So the next thing I'll do, I'll come to product. What product are we interested in? We're interested in Landsat 8. So I click, you can see you can use it to access other data sets, but we're interested in Landsat 8 OLITRS. So I'll click on it. So now the Landsat 8 we're interested in, what's our date range? You set your date range here. What number of results are you looking for? Then you equally set your maximum cloud cover. Like we know, optical remote sensing products are usually affected by land cloud cover a lot. So if you don't want anyone that doesn't have cloud cover, like you can see now as I'm hovering on it, I can see maximum cloud cover percentage. If you want, you can reduce it. If you want, you don't reduce it. So when you've set all these search parameters, you click on find. Now you can see it running here. And voila, it has found products for our area of interest. So it's left to you now. If I click on this one, on this, okay, it says unable to connect. I don't know why. Maybe it's because of my network. But if I click on it and I click on preview, it still says unable to connect. I think maybe there's an error with my net. There's an issue with my network. But if this is the one you want to download for use, all you have to do is you click on it. On like uncheck all these places that says pre-processed images, load band. Okay, you can leave load bands in QGIS because you want to use those bands, but I'll just uncheck everything and then you click run. When you click run now, it begins to download it begins to download all this it begins to download the data you've asked it to download. So that's what you do. And you can even specify the bands you want it to download and those you don't want it to download. If you don't want it to download band 1, band 2, all you have to do is you just need to be on checking it, and then you click on run. So that's how you use the SCP plugin. So I'm just going to close that, and I think we can move into the business of the day. So that's what we use the SCP plugin for. That's why I asked you guys to install it. So I'll just close it. So I believe you already have this data. So the first data we'll be working with is our 2016 data. I'm just going to unzip that. I believe everybody has unzipped theirs. I'm just going to unzip mine now. Okay, I'll just click on. Let me just minimize it. So while we are waiting for it to unzip, like I said, when we want to use these Landsat data bands to make calculations, there are some corrections we need to make, and those the every Landsat data you download always comes with a metadata file. As we know, metadata is data about data. So now I'm just going to show you the metadata file. So I just open this. So now when you open it, these are the bands. Like this is band 1, band 2, 3, 4, down to 11, and the ones we're interested in are band 10 and band 11. But if you remember correctly, they said we should studies have shown that we should refrain from the use of band 11. So for now we're interested in band 10. So this file here, the one with the text file with underscore mtl, this is our metadata file. So I'm just going to right click on it and I'll open it. So now this is the data about each band. Like now you can see this is the row and parts of the data. We equally have the cloud cover percentage here. We have the date it was acquired, and a lot of other things. Like we have from all those formulas in my slide, if you remember, this is the radians multiplicative band for band 1, band 10 and band 11. This is the additive band. So when you want to carry out all those calculations there by yourself, this is where you come and get all those calibration data parameters you need here. So these are the thermal constants that you need for band 10 and for band 11. So this is where you get them. So I'm just going to close this now. So now the next thing we do is, I believe everybody has installed this RS and QGIS data. So what we are going to do now is, this is what we are going to use to run our LST. The beautiful thing about QGIS is, for LSTs, you don't need to start carrying out all those tedious calculations by yourself. I'm going to give you an example. So I took time to break down all the data we need from the meta files. I created this in Excel. So now when you want to calculate surface radiance for band 10 and band 11, these are the multiplicative scaling factors you need, and these are the additive scaling factors. For brightness temperature, these are the constants for band 10 and band 11. So now equally see that I did a simplification of the formula of brightness temperature for our raster calculator. Now you can see how complex it is with a lot of brackets. So it's very possible now for you to make mistakes if you want to calculate this thing manually. That's by yourself in QGIS using the raster calculator, but somebody took it upon themselves to create this plugin, this RS and QGIS plugin. So with this RS and QGIS plugin, we don't need to use our raster calculator. All you need to do now is you just need to impute all the data you need here. That's all you need to do. You just need to impute all the data you need here. So the next thing we'll do now is we've unzipped our data. Okay, so we'll click on under when you open the plugin, the first thing you do is you click on select the mode of selection. You click on extracted files. Extracted files for a reason. When you click on extracted files, you have the it's at your discretion now to open your folder and select all the bands you have there. And select all the bands you have there. So I'm just going to click on extracted files, then I'll click on browse. Then you move to the folder where you extracted your Landsat data files. So this is mine. So when I open it, now you can see it tells us all the files to select. We are supposed to select TIFF files and text files. So what I usually do is you click on one. When you click on one, you press Ctrl A. It selects all the extracted files there. I'm doing this for a reason. This plugin that we are using now, you see, you can use it to calculate a lot of things. You can use it to calculate LST, brightness, temperature, um radiance correction, reflectance correction. So I'm going to calculate all of this. So I just click on all. When I click on one, I press Ctrl A and I select all of it. So I click on open. So now these are all the selected files for processing. You see our working directory here. This is the folder where we are working with. So now, like I said before, we are working with an area of interest, and that area of interest has a shape file. So the next thing I'll do is I need to select that area of interest shapefile. I'll click on this select area of interest shapefile. I'll move to where I have it, and I'll click the one with UTM, and I'll click on open. So now automatically you see it has selected clip data, but if clip data because I selected an area of interest. So for Landsat 8 data, exclude features. That's if you know that your Landsat 8 data has cloud cover or anything, you just select both of them. So now the next thing we are interested in is we want to calculate, if you remember the steps, we say we calculate radiance. And we are interested in the TIR band. You click on radiance for the TIR band. You then under extra derived outputs, we are interested in brightness, temperature, and LST. Now, this LST is actually calculated in Kelvin. If you remember, the SI unit for temperature is in Kelvin, but now this one gives us SI unit in degrees Celsius, because most people prefer to work with degrees Celsius. So it gives us our brightness temperature, that's at satellite temperature, and Landsat land surface temperature in Celsius. So when you've selected all of these, the next thing you do is you click on start processing. It doesn't even waste time. So as soon as I clicked on that, you see, this is our clipped. This is, and I click on clips. This is our clipped band 10. This is our clipped band 10 data for Makurdi, the local government. That's our area of interest. I'll move back and click on output. It's still loading. Okay, I think mine has an issue, so I'll just run it again. I'll uncheck top of atmosphere radiance and I'll uncheck LST. I'll run it again. I'll go to browse. Then we're interested in band 10. So I'll just click on one and I press Ctrl A. And sorry. And I'll deselect this folder. I'll open it. I'll click on LST. Now click on start processing. Please, if you are getting this same error like me, specify so we'll correct it together. Hello guys.
Yes, we are with you. So
Yes, we are with you. So we are with you.
Okay, so is anybody getting the same error like me?
yes, we are with you. So if there is any question, I'll kindly draw your attention to that.
Okay.
Did you hear me?
Yes, I can hear you. So which means nobody's getting the same error as I am.
Hello. Did you hear me,
Hello?
Edna?
Yes, I can hear you.
Sorry, if you can hear us from the comment section, can you kindly indicate, please?
Hello? Okay,
Hello, if you can hear me from the for the viewers, can you kindly indicate?
okay, so if you guys can
Okay,
hear,
I think
okay,
she's off. Edna,
hello, yeah, I'm back.
can you
I'm sharing my
can you
screen.
Edna?
Hello, can you hear me? Hello?
Hello. Yes.
Okay.
Yes, we can hear you now.
Okay, so when you are done running the processing, this I'm going to show you what I had. So when you are done running the processor, that's if you follow the steps, this is a folder you're supposed to get. So now basically what you get is this is your output data. So what it does is it gives you the clipped bands for your area of interest. Like now I have band 4, band 5, band 10 and band 11 clipped for our area of interest. Then you go back. Then for our output we have LST for band 10, this one here, and we have LST for band 11. So which means, excuse me, our processing has run and we have LST for band 10 because that's the only one we are going to use. So the next thing I'll do now is I have to add this LST for band 10 in QGIS. So what I need to do now is I'll go to layer, add layer. In this case, we are adding a raster layer. So I click on raster layer. Then I need to go to I need to go to this folder where we have our outputs. You need to go to the folder where you have your outputs. So I'll click on LST band 10 and I'll click open, add, and I'll close it. So in essence now what we have is we have our LST for band 10 for our area of interest. So the next thing I'm going to show you now is I'm just going to do a quick run through of how you do your symbology. So first things first, the first thing we do is we want to show the boundary of our area of interest. As you can remember, we added it before, so I'll just right click on it and click properties. Where it says simple fill, you click where it says fill, I'll click on simple fill. Then you see symbol layer type, I'll click on this arrow down here. I'll just leave it like that because I'm trying to remove the fill color. So I'll come to fill color, this arrow down again, I click on it and I'll click a transparent fill. I only want the border line to show. So that's our stroke color. Our stroke color, I'll leave it as black. Then our stroke width, I want it to be 1. I want the line to be very thick. Then I click apply. Okay, so this is our area of interest. So the next thing we need to do now is we need to rename this layer. The name is actually too long, so I'll right click on it, rename layer. So this data now is for 2016. So we have LSD band 10 underscore 2016 and I click on enter. So the name is okay now. So I right click on it. We need to do a symbology for this. So what we do now is we go to properties. Now under properties, you see information source. Symbology is the one we're interested in. So you click on symbology. So under symbology now we have renderer type. I click on renderer type. Then I click on single band pseudo color. So when I click on single band pseudo color, this is the color we have now. But now we usually we relate red to when something is very hot. So now as it shows now, red means the lowest temperature in this area and blue is the highest temperature. It seems weird to me and I think it should seem weird to you too because something that is blue cannot be hot and something that's red cannot be cold. So all we need to do now is we need to invert this color ramp. So you click on this arrow here by the color ramp and you click invert color ramp. So when we scroll down, we've inverted our color ramp. You come to mode. We want it to be in equal interval. So you click on equal interval. Then I click on apply. And then I have I'm just going to do okay, yeah, that's all I'll do. So I just click on okay. So now for this area, we are having all these areas now to be the places with high temperature. These are all the places with very high land surface temperature. So if you want to do any other form of analysis, like basically this LST is usually related to NDVI, but for the fact that another facilitator is going to be calculating NDVI, I don't want to delve into that, but I'm just going to put it out there. Studies have shown that where you have NDVI values to be low and negative, LST is usually high there. And where you have NDVI values to be very high and very positive, LST is low there. So the next part of our analysis now is I'm going to show you how to get points, like I'll call them test points if you want to carry out an analysis using this LST data you've been able to generate. So the first thing we do is you go to your processing menu, you click on it, you click on toolbox. and it opens up. So the first thing you search for is create. You search for create grid. So this is the one we're interested in. You double click on it. So the grid we're interested in searching now, we want test points for every 2 kilometers on our area of interest. I did something similar like this yesterday. So our grid type, we want it to be rectangles. Our grid extent, we want it to be for our area of interest. So you click your area of interest. We said 2 kilometers, so change this to kilometers. Our horizontal spacing will be 2, vertical spacing 2. Now, if you notice, I'm not saving. I'm going to be leaving it as temporary layers, but you can save the layer. So to save the layer, you just click here, save to file, and you specify. So I'll click on run. Okay. So this is our grid. So I don't want this grid to have any color. I'll right click properties where it says color. Sorry, simple fill. Where it says fill color, I'll leave it as transparent and I'll apply. So this is our grid. These are 2 kilometer grids covering our area. So the next thing we do is we need to create centroids. These centroids now are our test points for every 2 kilometer grid we're interested in. So the next thing I'll do now is under processing toolbox, I'll search for centroids. I'll search for centroids. So I'll click the one under vector geometry. So now the centroids we're interested in creating for what layer? We're interested in creating centroids for our grid layer. So you select your grid layer. To save it, you click here, save to file. But I'm just going to leave mine as a temporary layer. So I'll click run. So I'll close it. These are our test points for every 2 kilometer grid in our test area. So the next thing we do is I'm just going to switch grids off. So these are our test points. But you can see that these test points also fall outside our area of interest. So now we want these test points to be within our area of interest. So that now leads us to we now want to clip. Clipping is a tool. When you clip, you don't only clip raster files, you can equally clip vector data files too. So now I'm going to show you how to clip vector data files. Back in your toolbox, you search for clip vector by mask layer, and then I'll double click clip vector by mask layer. Our input layer is the centroids, and then our mask layer is our township, which is our area of interest. Your mask layer should always be your area of interest. You save that again or you leave it as a temporary file, then you click on run. So I close it. Now you can see the difference in color. Our centroids were in orange color before, but now that we've clipped, we have it in pink. Pink. So I'm just going to switch this layer off now. So you can see we have our test points for our area of interest. So now, what's the reason of getting this test point? We want to know the temperature for each of these test points. So to do that now, what we do is we are going to run another tool, and that tool is called add raster values to points. So to do that, we have we're going to search for add raster values to points, and it comes on. So I'll just click on it. So now that we've clicked on it, now Which points are we interested in? We're interested in our test points. In my case now, that's the clipped mask. I click on it. So now, grid. Grid now is trying to, what grid means in this place is not this grid you formed. The grid it's asking you for is your raster file, which is your LST file. So what you do is you click here and you click this LST band 10 and you press here to go back. Interpolation, I usually prefer to use nearest neighbor, so I just click on nearest neighbor interpolation, but you can just play around and pick any of these other interpolations. So I click on nearest neighbor and I'll click run. So you can see it's running here. Even if yours begins to say not responding, it's not a problem. So it's just the tool will run and then it will add raster values to the points. So while we wait for it to complete, so you can see task complete. So I'll just close this. So now I'll switch this off. So these points now have temperature values added to them. How do we know that? You right click on it and you click open attributes table. So now that we've opened attributes table, we can now see we have this point here now. So we have these points here and they all have temperatures. So I'm just going to close our attribute table. I'll close this now. The last thing I'll do now is we are going to add our OpenStreetMap layer. You click on web, quick map services, OpenStreetMap, you open your OSM standard. So now this is our area of interest, and for this our area of interest I'm going to switch off this the shapefile. So you can see these are all these points have temperature values attached to them. So I'm just going to open the attributes table again. So if I click on this point now, this point, okay, sorry, let me clear my selection. Now if you click here, this shows us the points with, from our test points, it shows us the points with the highest temperature for our test area. And if I click again, it sorts and it shows us the points with the lowest temperature. So if I just click on this one and I scroll down and I click on the other one that has the highest temperature, so I just minimize our attribute table. So now we can see the 2 points that have the highest and the lowest. One actually falls on River Benue and the other one falls on somewhere that seems to be a place with like a bare ground. So like I said previously, where NDVI has low or negative values, LST is high, and where NDVI is high or has positive values, LST is low. So from this now, we can see that this place now might actually be the place with the one that falls on the river might actually be the place with the highest LST value, and the one that falls on the background is the one with the low LST value. So I think this brings us to the end of our LST analysis with QGIS. Thank you.
Oh, thank you so much, Edna. This is a very wonderful section. I'm just watching. Now I wish you would stop. Just keep going. You know, from our viewers, I don't know if you have any comment. This was a very wonderful section. So I think this is a research question. The why there is no balance between the figures for NDVI and land surface temperature. It's obvious actually because NDVI is vegetative index,
Yes.
and this is surface temperature. But I think if anybody is in of that research, it's something we need to find out why there's a variation. since we are using, let's say, the same satellite imagery and we are having
Imagery.
different value for the same spot, yes. So that was a very wonderful section. And there is no comment for now. So I think everybody is just, amazed by the presentation. So without wasting much of our time, thank you so much, Edna. We would like to welcome Chidima. We'd like to welcome Chidima. She's going to take us on land use and land cover classification. Remember hot sensing and hotspot and image classification. So now we are going to go straight into how do we classify land use and how do we classify land cover. And that's it for today, aside the surface temperature. I think, Edna, you have a question. Maybe we answer it before Chidima starts. The question
Okay.
is, can we process aster thermal bands? Can we process aster thermal bands the same way with this plugin?
Okay, is which of the plugins? Is it the SCP plugin or the RS and QGIS plugin?
I think the RS, the
Okay.
plugin you have just used for the
Okay.
modeling.
If you remember, when we opened it now, it asks us to click selected files. So if you are using Asta data, where it says for Landsat, its data exclude features, you won't answer all those questions. Excuse me, I think you can use it. I haven't worked with it, so I'm not sure, but I think you can use it for Asta data.
Yes, I think you can also
Yes.
use it. What matters is the thermal bands you are using.
Yes, it is. If
Um,
once it has
okay,
thermal
so
bands, I think you are good to go.
yeah. Thank you so much. I would like to welcome Chidima to the section. She's going to take us on land use and land cover classification. Welcome, Chidima, to today's section.
Hello, everyone. Thank you, Nina. Edina, that was a very interesting class you had now. Thank you. So,
Thank
without
you.
wasting our time, I'm going to jump in straight to sharing my screen. Okay. When Edna was having her class, she showed you how to install the SCP plugin. And we're also going to use that same SCP plugin for our own analysis, for land use land cover analysis. First of all, I think if you have already downloaded the data sheet shared via her Google Drive, please make use of it. But if not, I'm just going to show you a quick way to download Landsat. I showed it on the port day using landlook.usgs.gov. I'm going to share the link with the admin to send to you via YouTube. Please, over here, can you see my screen? Hello, Nina.
Yes, but not. Yes, I can see your screen, but I think you are sharing your entire screen.
Yes, I'm sharing my entire screen. Okay, please, on a quick one, you can the data I use, I got it from this software, from this website. Just set your parameters, check your date, the year you want to download data from, check your the months, the cloud cover. You click on zoom in. When you click on zoom in, it will click to zoom up to where you are and you show you the images. Click on show images. So it will take time for it to load. When the images load, hold on a moment. Okay, while now is loading, please make sure that you have this same interface as mine on your QGIS, that your SCP plugin is activated. Please kindly do so. Okay, now the image has loaded. So you can see all the land use Landsat available for this particular location. Oh. Now you click on show metadata. This will allow you to download. Once you get the one you want, if you are looking at the cloud cover, this has 0 cloud cover. And this is the pattern row. This is the date of acquisition and the year. This is the sensor. You can get the details here. You can now download. When you click on it, you can now download either via this. This is the standard product, that's in the whole Landsat product, and this is the landed product. But go for standard products. You click here to lead it to download. Now I'm back to our SCP. Okay, now on your toolbar here, you click on this to activate this menu. First of all, load the band sets. To load the band sets, you can go as far as doing a pre-processing to remove any haze and give you a better imagery to work with. But I'm going to skip this because it takes time. So I'll go to band sets, click on this, then navigate to where you save your Landsat data. Mine is saved in work documents, which is folder, and this is my Landsat data. I've downloaded already. So I'm just going to Control A to select everything, leaving out this, and this. I just need the images, not the whole data. So I'll click open. You see that the images I clicked has already loaded here. Now, coming down to band set 1, this is our image. For this analysis, we are going to use band 1 to 7. We only need band 1 to 7. So over here, I'm going to select band 8 to band 12, band 8 to band 11 and BQA. I'll come over to this. You see this arrow buttons here. Click on the minus to delete the row. Say yes. Now I only have band 1 to band 7. Now, next thing you're going to do, you have to set the wavelengths. So over here, you see wavelength quick setting. Click on it. Navigate to band Landsat OLI bands 2, 3, 4 to 7. You select it so that the wavelengths have changed. And the wavelengths have changed. Now, having done that, we come down to these boxes down here. We click on create visual raster band or band sets. Create visual raster of band sets. Once you're done, click run. Now, when you have it, you have to create a folder where it's going to be saved. So I will go back So this, I've already created this folder called corrected. I intend to save my band, my virtual band, raster band set in this corrected folder. Select folder. Now, everything has been loaded here. These are Landsat date bands. I'm going to uncheck these ones. They're going to work. This is the virtual band we just created right now. So you're going to work with this virtual band. Now let me show you what it means by this virtual band. When you right click on it, properties, you go to metadata. No, go to symbology or information. Go to information. It will show you the number of bands contained within this virtual raster band set we just created. You see all the bands we have here, band 1 to 7 are well represented. So we go back again, we say cancel. Now, I'll be removing this Landsat data because I don't need them anymore. Now, we will not be working with the whole band, with the whole raster. You need to create a study area map or a study area or area of interest. So I'm going to click on this to create new shapefile layer. You give it a file name. Select your folder, ROI. If you are working with polygon, click on polygon, click OK. Now we have our ROI here, but it's empty. So we have to first of all edit, toggle editing to create the ROI. Now I'm going to just click on anywhere I like and create a polygon there. Give it a ID, and I'm done. You save your work, you save your created folder, your shapefile. Always remember to save your projects. Now I'm going to change the symbology to no fuel using this one. Apply, say OK, save. Now, using this arrow, I'm going to clip out the area of interest. Since I don't want to work in the whole raster file, I go to processing toolbox. I'll click on clip raster by extent. You find clip raster by extent under GDL raster extraction, clip raster by extent. See clip raster by extent. You click on it. It will bring us here. Our input layer is the Landsat, the rubber set we created. Then the clipping extent is our ROI. I'm going to save it to a folder, to a file. So under here, we click on save to file. I'll navigate again to my folder, corrected. You set ROI underscore clipped. Save. Then you run. Now we are done clipping, we close. Zoom to raster layer, zoom to layer. So this is where we will be working. This is our area of interest for now. Now, going back again to our SCP to commence our analysis, since we have deleted this, so I'm going to clear it, refresh, then refer back to the clipped arrow I assign it again, band 8. These are the bands. See arrow I clip band 1, band 0, that is band 1, band 1, band 1, band 2, and all this. Just click on to assign the proper bands to it. Then you say run. Select again this one to save it there. Now we have this having assigned the proper wavelengths to it. Now the next step again now we have to do is to go on with creating a band composite. Band composite help us to know the features, to recognize the features based on the spectral reflectance. They help us to recognize, because now here we have the blue purple color here. I don't know what it means. We have white here. I don't know what it means. We have gray, brown, green. I don't know what it means. But once I'm able to create a band composite, I'll be able to identify what those colors mean and the features on ground. And to do that, I'm going to write. I'll delete this so we won't have any confusion. I'll right click on it, go to properties, then go to symbology. We still have the same data set, so go to symbology. On this symbology, I have band rendering. I'm going to render type is multi-band color. I will choose that. Then over here, I'm going to change the bands. I'll select band 5 for my red. Are you following?
Yes.
Then select band
We are
4
following.
and band 3. Then leave everything at this, everything as it is. But make sure the statistics extent is whole raster, or you can say current canvas. Accuracy is estimate, faster. You keep to that. Then you click apply. Now the colors have changed. So okay. Now we have first color composite. In first color composite, based on remote sensing and spectral signatures, this blue color here refers to built-up areas. These shades of red refers to vegetation. Shades of red refers to vegetation. Here, this color here, this darker blue or gray color refers to, seems like where we are is a rocky area, so it is going to be a rocky area. Bear it in mind that when you're done doing a Landsat analysis and image classification, you should have an idea of where you are. So it's not for us to guess ourselves or to second guess what you're doing. We're going to add OpenStreetMap. Click on web, go to quick map services, select some open streets. Okay, or you can go for anyone that can give you a satellite view. Let me go for Google. I was hoping to get a higher resolution imagery. Okay, let's keep zooming. Yes. So on our ROI, on our clipped raster, you can see that the blue overlays the built-up areas we have here, and the red we have here is in line with the vegetation we have here. So I'm going to zoom out to get to those these blue guys here, this blue color here, to know what it means and what it represents on ground. Or it seems like it's a marshy area, not. Or it's a vegetation, but it seems there's a water, a river flowing through. This is a water body. That means it's a marshy area or a riparian vegetation environment. Now, note that though this is a vegetation, there are many things that can change the structure of the vegetation. Like when you have a water present within that vegetation area cover, it's going to reflect differently. Check again what you have here. We have blue, red here. This vegetation. Here we have another color, the blue, dark blue color, dark green, gray color. But on ground, what you have here is vegetation with tints of baylands or open surface. This is an open surface. So you can classify this color to be open surface based on the reflection we are getting. So one have to have an idea of where they're working to be able to interpret the images very well. Over here, we have a blue color here. That means we have a water body presence here, and it's aligned with what we have on ground too. So a proper knowledge of your environment or of your study area can help you to do a proper analysis. When you're in doubt, it is always proper to go on a field work to be able to identify the features. Like over here, I was saying maybe it's a rock environment, but this seems to be a bayland or open surface. So this blue color, unfortunately, had the same color as our built-ups. Had the same color as our built-ups. So we are going to use maximum likelihood to classify this to get a near accuracy in our analysis. Now, having done the first color composite, we go ahead now to save our project, then to create training data to be able to train the software to carry out the classification. Now
Okay.
I'm going, because I closed my SCP doc here, so I'm going back to lay and view panels, click on SCP doc to bring me here. Now, if you're on this same page as mine and you're having the same interface, over here, you see the ROI options, you see the training inputs, you see home. We're going to work with these training inputs.
Hello, can you hear me?
I can hear you.
Okay, yes. Sorry, maybe you can tell us what type of classification you're doing, because on day 4 you mentioned the types of classification. So maybe you can tell us the classification. Then another person has a question.
Okay.
How does color tell you about the feature? So for example, vegetation or rocky area.
Okay. First of all, I'm doing supervised classification. I mentioned that on the report that it is better to do supervised classification than do unsupervised classification. You can only use unsupervised classification in an area you're not familiar with. But an area you're familiar with, you use supervised classification since you're sure of your environment. Now, how does color tell the different features on ground? We have spectral indices and spectral database. Now, this is not, I showed us the other day what the band stands for, and okay. Now look at this website, water bodies. You will find the different reflectance responses for the different features on ground and what they can reflect on your image classification. The spectral reflectance over here, I will send the link to you so you can go through it when we are done with the class. Please, Nina, help me to post this. There are several what do you call it? Spectral reflectance that helps us to do our classification. That's why before you do any classification, you have to have an idea of the spectral signatures, what they reflect, and what each band combination ought to do. Now, we are using 543, that's color infrared, also known as false color composite. This band combination also is good for analyzing vegetation. Here, in particular areas in red have better green. Red color represents vegetation. Dark areas are water. Urban areas are white or blue. It depends on the area. So you have to read up on the spectral signatures and what each band combination shows you. Assuming we use 762 for our analysis in our band combination, we will be studying geology to give us geological formation, lithology features, and faults. For bathymetric analysis, we use 431 combination for it. It will give us information on water bathymetry, aerosols, and suspended sediments in water bodies. For agriculture, you use 652 for crop monitoring and looking at vegetation health. So we have various band combinations, and they have different work or operations or what they review in your band combination. Now, going back to our classification, we are using 543, which is show vegetation as red, built up areas as blue or white. It depends on the area. For us here, our built up shows as a shade of blue. The water body is showing as blue, as blue here, but it's darker than our built up areas. Then the bare lands here, this can be a bare land or a farmland. So with the help of your land grant data, you can identify what each stands for. So as you can see, this seems like normal vegetation, but it's sparse vegetation and not a dense vegetation, because the different colors, the red ranges from light to dense vegetation. From light red to dense darker red means from light vegetation to dense vegetation. Now for our classification, over here, if you are here with me, please try to remember to save your work, your project. Click on this to create a no training input. That's to create the training data, the polygons we're going to use to classify our data. I'll click on it. Still on this corrected folder, I'll name it ROI training, ROI under training. Save. Now, in using SCP to classify your images, we have different types of, we have a macro class and the micro class, MCID and CID. This MCID refers to the general terms. Like if you have vegetation, under vegetation, you now have different classes. That's like light vegetation, dense vegetation, farmland. The main body, the main name or the main class is vegetation. We are going starting with vegetation to create our data, our classification. Then under here, the class minor class name, I'll input sparse vegetation or sparse forest. Now note that the IDs are different. The more I create micro classes under this macro class, the ID of the macro class, that vegetation, will remain constant, but the micro class, the CID, will keep changing. Now, since we are already giving them the name, giving the names here, I'm going to zoom in. Now, remember I said that the lighter the red color, the lighter the vegetation, but the denser it is, this is a darker color, the denser the vegetation. The darker the color, the denser the vegetation, but the lighter the color, the lighter the vegetation. Why light? One, the light red reflection we have in here signifies younger forest, signifies new forest, maybe regeneration, secondary forest, but the darker color refers to the primary forest, that is the older forest. So you can say that the light one is primary forest, the light one is secondary forest, then the dark one is the primary forest. That's the older forest or dense vegetation or dense forest. Now to create our training data, over here on my toolbar here, this for ROI, create ROI polygon. Once you click on it, this, you see, is giving me the spectral signatures of the area, helping to identify where I am and what it stands for. I talked about the spectral reflectance. So for this area, this is the spectral reflectance. And since all of them are within this almost the same range, that means they're the same. You have minus 0.044. But over here, you have 0.039. Can also guide you in creating your area of interest, your training data. So since these areas are the same, they're within the same range of 0.43 to 0.45. That means that it's of the same class. So I'm going to click on it. Click however you want it to be. Now, when you're done and you reach the end of your right click, you come over to this place where you've already inputted the class of the vegetation and their group name. You click save. Now it's saving. It's not saving, it is very complete. You now do the same and classify. other features. Using their spectral signature, you group them. Now let's allow it to run fully.
Can you maybe take some time to maybe explain why you are selecting a larger polygon, a larger area size for your training data?
It doesn't matter whether it's a larger area or small polygons. For me to save time for me, I'm using this one so as have more pixels of the
Yes.
same spectral signature under the same area. So that when you are classifying, you have more pixels to classify with. I don't know if I'm clear.
Yes, it's just to answer some, maybe some people might be curious as to why. So,
Okay, you can use smaller polygons, but since I have a larger concentration of these spectral signatures here, I tend to gather as much as I can because the bigger your training data, the more accurate your classification. Now, having done with vegetation, the light vegetation here, see it has already saved. Now you can see that our micro class ID have changed to number 2. This one, and the group name is vegetation. Under the CID is 1. So for the second class name, I'm going to use dense forest. So I'll navigate to areas you have a darker shade of red. Since you have a darker shade of red here, um let's see another area we can use. Please not mind that I'm using it's better once you have this kind of area and big study area. Please correct as much samples as you can. They just a training. Please don't just use one for sparse. Collect as much of sparse are covered across this study area as you can. So I'm going to create another sparse here, sparse vegetation here. So this another red shade of light red. So I click again. Okay, I'll change the name here again, sparse 2. Then come over here, select click again, select, then create the signature and allow it to load and everything. And please make sure that over here that it is on auto save. I mean that the signature is being saved in the database so that when even your laptop goes off or anything happens, your training data is not lost. Please always make sure that it is on auto save. So allow it to run. It's calculating the signature. Allow it. Once it's done, you keep on. I'll classify just 3 surfaces here. You will work with it for now. And when you go home, you do a more detailed classification to give you a more detailed analysis. All right, so we have 1, 2 here. You note that the CID over here changed again. So we're going to name the next one dense forest. Dense forest. So we try to find where we have the dense forest. That's the darker shade of red. Seems to have one here. but it's mixed with the light shade, but we're going to use the majority here. You have more of dark shade of red here. So you click on here again, use a polygon, grab as much as you can, then you save again. You see, well, I think when you're working with a smaller area, it loads faster. But when you're working with a bigger area, it takes time to load because it's calculating the signature of a larger polygon. So if you're in a hurry, you can use as small polygons, but be sure that the signatures are different. So you don't have issue of having miscalculating or misclassifying your data. So once it's done, we move on to another class. Allow it, good. Then we are moving on to, we are going to change the macro class ID to 2, change it to built up. I can say urban area and settlements. Settlements. Then on the class name, class ID, change it down to 1, because this is the first one in this macro class. Change it to built up. Built up. So we are going to navigate to where we have our built up areas. Remember I said over here is the blue color. And if you are not so sure of what you are doing, please use your Google satellite imagery to be sure of where you are. You see, this is a built up area, this is an urban area. So we are right in classifying this area as built up. So the blue here reflects to a built up area. So I'm going to use the dense color, is more dense here. So I'm going to use this area for my classification. I'll click on here again and go. Wow. Now, the pixels here that I selected are more purer, are the same than over here. This is the built up area, but you have mixtures of other classes within it. So that's why I chose this denser area to get my pixel from. So I will save again, allow it to run, save again. Next one we're going to do is for open surface. Then we run our analysis, our classification. Now, when it's still loading, I'll also show you how you can change the colors, to what you want your classes to look like. We just do one more. That's for open surface, and we're done with the classification. We now run our classification. Okay, we're done. Now the next, we change the macro class ID to 3, then change the class ID to 1, then change the name to open surfaces, our third class, our third classification, open surfaces, bare lands, bare soil. Now the bare soil is a class under open surface. So we navigate to where we have potential bare lands. For example, here, this looks like a bare land. We have to verify whether it's a bare land or not using our Google satellite. Oh, this look more like a farmland. This look more like a farmland than a bare land. But we have bare lands in between them. And this is like a cleared deforestation. This is a huge forest environment. That means here is being cleared. That means we are losing vegetation over here. But we are going to look for a pure bare land to classify. I think we have one here. Looks more like it. We have some bare land here. So we can use this area as our bare land, but unfortunately, this is not it. So we keep on checking until we see a bare land we can classify. So I think it's even proper for us to classify this as farmlands, since it's showing this color. So we classify this as farmlands. So we change this to one, then upgrade this to 4 and name it farmlands under vegetation class. We just classify it. So anywhere the training sees this pixel or reflectance color, it will actually classify them as farmlands. So we add again to our signature. Then we have one more to go. That is the open surface. Then we are done. Any questions so far? Nena?
No question.
Okay, if I'm moving too fast, please let me know. So we wait for you to run. Remember to save your work always. So we move on to finding a best surface that we can use. Let's see what this color signifies. I think it's safe to classify this as bare lands. It's more of an open surface than a vegetation. So we classify this color, this dark blue, as our bare lands. This dark gray as our bare lands. So since you have a higher concentration here, I'm just going to pick from here. Oh, we have not actually done this here. We almost missed it. Please remember to always change your macro class ID and your micro class ID to avoid mix-up. Best soil. So we save. Okay. We wait for it to be done calculating the signature. Okay. All right, we're done. So save. So now to change the colors here to reflect how I want it to reflect when I'm doing the classification. The best soil are okay. The settlement, I'm going to change it to red. So I click on the settlement, highlight it, I right click, come to change color. I select red. I like using red as my settlement. For built-up color, do the same, change it to red. For vegetation, I'm going to change it to green. But you're going to be in graduation. For sparse vegetation, I'm going to change it to a lighter green. This seems okay. Then for the second sparse vegetation, I'm going to use the same color for it, since they're the same class. Then for dense, I'm going to use a darker color shade of green. I will use this. Then for farmland, I'm going to use another shade of green. This is okay. Use this. Now, having assigned these colors to it, next thing we're going to do is to run our classification. So go back again, click on this to run our classification. We click on OK, it's open here. Then we navigate to band processing, classification. Remember that your input band set is this, the one we've clicked. So make sure that your number set 1 reflects the same thing as your band inputs here. So you're going to use either use the macro class ID or use the just minor class ID. So I'm going to use minor class ID for now. For the algorithm, you're using supervised classification. So click over here, you use maximum likelihood classification. Now for the non-cover signature class, you will use the algorithm and the LCA. Then to get the, what does it mean? The non-cover signature classification, you click on here to give you a table here. Now these the ones overlapping themselves. You can choose to ignore it. I'm going to ignore mine. Due to time, we don't have time on our side again, so I'm going to ignore it. Go back to classification, click on that. Over here, they load the class. I'm going to ignore it. I'm going to create classification reports. Then navigate to where to save. Not create vector. Sorry. Once you're done, you run. Once you're done setting the parameters here, classification reports, you click run. Then back to my corrected folder, I'll write it maximum like ML over underscore land use land cover analysis. I will save. Then it's classifying. We give it time.
I think while we're waiting for the classification to run, maybe we can take questions because of time. Can you hear me?
I can hear you. It's okay.
Okay, so someone is saying, what do we do with imagery with cloud cover before classifying? So how do we correct Landsat 7 imagery with cloud cover before classifying?
Actually, in a real sense, there is no way you can remove cloud cover. That's why it's always advised to go for image that doesn't have cloud cover, zero cloud cover percent. There is no algorithm to remove cloud cover. And if you try to remove it in some area, they will give you a way of removing it. But that portion of that portion, assume we have a cloud cover here, and you remove it, this portion will be lost because it's going to give you a black or a blank space. So it's always advisable to go for data that doesn't have cloud cover at all. Now our classification is done. It seems that everything classified as all the built up classified as best soil. So we are going to rectify that by creating more spectral signatures for this. But
Area of interest.
I can hear you. But due to time now, we're going to leave it like this. At least you have learned how to do the classification. So we're going to leave everything like this. For here, we have the green colors stand for stand for dense vegetation. The light green stands for sparse. The brown stands for best soil. Unfortunately, our built up area didn't come out as much as you wanted to. So, but due to time, I'm going to leave it like this. Now, when we are creating, remember we saved, we asked it to create a classification report for us. So you're going to see how that look like. Create classification reports. Select the classification. We are using all this. We are using this. Then run. Now, what it does is that it shows you the total area of your classification, the features, how many percentage of area they have covered. So now for class 1, 2, 3, 4, that's vegetation, built up, settlement, and non-classified. Remember, we are moving with what we have here. These are the classes. 0 here is unclassified. This, we don't have 0, but we have 1, we have 2, we have 3, and we have 4. And 1 stands for sparse vegetation, sparse forest. We have dense vegetation, we have farmlands, and bare soil. So this is for bare soil, which is the farmland is 4.0. This is the area it covers in the whole of the study area. This is the percentage. Then this is the pixel sum. So with this, you can, if you have like 2 different years, it can help you to run. You can generate your change detection numbers from here. You help you to check, see how much these have reduced or increased over time. So due to time, we'll be stopping here for today. Any question, please let me know so I can answer it before our time goes. Thank you. Nena, are you here? Hello, Nana.
Hello, can you hear me? Thank you very much, Chidima. Can you hear me?
I can hear you.
Hello?
Hello, I can hear you.
Hello?
Hello.
Sorry for the viewers, if you can hear me, can you just comment on the live comment section?
Okay, can you hear me?
Yes, we can hear you.
Okay, I saw a question asking on how to correct Landsat 7 image with no SLC, that's
Yeah.
scan line error. Actually, there's a way you can do so using QGIS, but I don't have. There's a way of filling it or filling in the no data, fill no data. Under your raster, you go to analysis, fill no data. You input the band you want to work on. You follow the prompts and run and it will help you to fill the data actually. But but you are going to lose some information there if it's not done properly. Have I answered your question, Ibrahim?
Um, well, I think he might have to comment on this section for us to know if we have answered his question. So thank you very much, Edna and Chidima. Today has been a very wonderful section. I myself I'm super excited. I'm just happy since the beginning of this section. It has been a wonderful section today. And tomorrow, we have another section tomorrow. And tomorrow is going to be our last day for the 7 days training. So we know we might not be able to cover as much as we can, but because of the time constraint that we have, we are limited to 2 hours per day and 7 hours for the entire duration of the section. So for those that are actually asking for cloud cover before classifying, we really appreciate not apologize for not covering that aspect here because of time constraint. Before you do anything with your imagery, depending on the type of imagery you're using and the resolution, there is image processing, which is a different ball game. It's also another aspect of geographical information system and photogrammetry. So maybe you can look into that. You can look at how you can do cloud masking using EDAS, Imaging, or MV. But like Chidema said, you can't actually remove completely cloud cover. So it is best you look out to download imagery and without cloud cover so that you don't find yourself in classification errors. But if you want to look into that, you can look at cloud masking and you can look at elders emerging MV and the likes of them. You might find it interesting. Look at some resources on image processing and photogrammetry. Those ones are pre-processing for imagery before you do the analysis we are doing. So we are concentrating on the proper analysis. So like I always say, thank you so much, everybody. Thank you, our viewers. Thank you, our facilitators.
Hello. Hello, sorry I'm cutting it. Ibrahim has another question here. Asked
Okay.
here, was like,
Yeah.
what's the advantage of QGIS over EDAS, MV, Google Earth Engine?
Okay.
Actually, EDAS and MV are commercial software. You have to pay
Yeah.
for them, but QGIS is free. Google Earth Engine is kind of way better than QGIS if you have an idea of, or experience of programming. You can understand the algorithms there, but if you can, it's better for you to use QGIS. It's much better, simple, and you can actually work around it. But if you have an idea of programming, you can use Google Earth Engine to run your analysis. For EDAS and MV, they're quite okay if you can afford to buy it. That's all. Thank you.
Okay, thank you. So, Barakat, you joined late. How will you be able to meet up with the section? So the video will always be on the portal on our YouTube channel. So always do find check for the image and the training section you missed, and try to see if you can follow up on the presentations that you missed. Like we said, we also have share the registration link for those who are not able to register from the beginning. This is to enable us send the assessment to everyone, and also to enable us make the certificates ready for everyone. We don't want to miss out anybody in any way. So that is why we have decided to open up the registration link for that purpose only. So tomorrow is going to be our last day, and we look forward to seeing you tomorrow for watershed analysis and NDVI for vegetation. So thank you so much for joining us today. We look forward to seeing you tomorrow, 6 p.m. GMT +1.
Hello,
Thank
Nina. Hello.
Yes, please.
Sorry, I'm going to cut in. For tomorrow's class, we're going to be using these plugins. Please, if you can see me, you can see my screen. Oh, I'm not sharing my screen. Sorry. I'm sharing my screen now. Please, sorry for taking your time. Please, for tomorrow, we'll be using SRTM downloader. Please, when you go to your plugin, look for SRTM downloader. Please download it. Look for QSWAT, QSWAT Plus, QSWAT Plus. Please download the software, these same plugins. If you cannot find it, I'll quickly send you
The
the,
link.
the link to it so you can download it ahead of time, because we're going to use it for our analysis tomorrow. Please, this is it. So I'm going to send the link to Nena to post on here. So please download the QSWAT. You depend on your own operational machines, 63, 64, or 32. Please download this. Install the SRTM downloader ahead of time, so when we come tomorrow, we just get straight to work. Thank you.
Okay, thank you so much, Chidema, for that. Also, thank you, Edna, for a wonderful section today. So we look forward to seeing you tomorrow, which is the last day. How I wish the training will never end, but unfortunately, we have to stop somewhere. This is to allow us, assimilate what we have learned. We look forward to many more training sections, and we know we are going to be seeing ourselves once again. So thank you so much, and we'll see you tomorrow, 6 p.m. GMT +1. Thank you. Bye.
Bye. Bye.